friends and colleagues. Welcome to another edition of Fred's Corner. Fred's Corner is here to provide some state-of-the-art solutions for well construction problems. Great privilege today is to present a topic which is near and dear to a lot of our hearts in the oil business. Looking for CO2 resistant materials for wells. RiLOCK resin, I'm going to propose, is the best zone isolation solution to combat CO2. And this corrosion in wells is pretty dramatic, but RiLOCK is the best solution. Let's talk in general about CO2 and cement. There's a lot of wells these days with floods, CO2 floods. Hydrocarbon production a lot of times produces CO2, and storage of CO2 is dramatically increasing over the last years and will in the future. A couple of things that are problematic with CO2. There's a reaction of CO2 with the cement itself. It converts it to calcium carbonate, and by that process, in the presence of the weak acid, carbonic acid in this case, it dissolves and creates additional permeability. And so that cement begins to lose its seal and lose its integrity. Guess what? There is a solution to this problem. It's called RiTex resin. RiLOCK resin is our official name for it. Let's look at RiLOCK resin in general. What is it? It's a multi-component system. You could almost think of it in terms of three parts. Part A is the sort of the resin, the diluent, and the bonding aids all wrapped into one. Part B is the hardeners. We have hardeners dependent on the temperature and the application. There's multiple hardeners or combinations that we can put together to make it perform where we need it to be. This particular material is unweighted resin. We can add the hardeners to make this set in this unweighted case. It's about 9.2 pound per gallon. But we also have specialized weighting agents that you can put and increase the density to as high as 16 or 17 pounds. In my left hand is a 16 pound per gallon resin that's been weighted up with conventional barite, but we have specialty materials that we can use as well. It has some very remarkable properties. What are those? The mechanical strength, resiliency. It's very resistant to corrosion, and that's one of the key things about CO2, right? And flexibility in design, because we have this ability to design it for specific well applications. It's very flexible, and in our position, in our thought process, it's the most flexible in the industry. We're here to talk about exposure to CO2. So let's talk about the RiLOCK resin and its exposure. So we did some tests. This has been a while ago, but we did what we called accelerated cure tests, where we took elevated temperature tests and exposed it to CO2 and try to then predict what would happen at lower temperatures based upon this accelerated cure. We did this at 225 degrees F, 275, and 325. Much higher temperatures than normal for CO2 resistant materials. We submerged these in aqueous fluid at 1,000 psi CO2 pressure. We did up to 6 weeks data looking at things like tensile strength, density, dimensional change, and really even chemical change. And I'll discuss that a little bit later on how we did that. Here's an example of the resistance of two different resin systems at 220 degrees. From the baseline, before we put them exposure, up to 6 weeks at exposure. Look at the change in tensile strength, virtually none, over the 6 week period. In one case, we had over 3,000 PSI tensile, in the other case, over 2,500 PSI, with no drop in tensile strength over the exposure period. Now, as I said, we did elevate the temperatures greater than 220, so let me just show you a couple of other data points just to help you understand at elevated temperature how successful it was. Well, at 270 degrees, we ultimately got about 1,400 PSI when it was exposure to CO2, and at 320, about 1,100. Well, that is a drop in strength compared to what we had at 220, but that's above the glass transition temperature. So what we did is just compared it with exposure in water at those temperatures. And guess what? It's exactly the same, or in fact, in some cases, maybe exceeded a little bit. So it wasn't deteriorating due to the exposure to CO2. It's the normal drop in strength as we see with elevated temperatures. Well, let's look at a table that sort of summarizes the way to evaluate materials to control CO2 corrosion. Let me walk you through this so you understand what I'm talking about. We have a property. The properties we're going to focus in on is the calcium silicates. That's the active material that you can change and react with the CO2 to form calcium carbonate. The second is permeability. The lower the permeability, the better. Bonding. If you have better bonding, you limit the ability of the CO2 to pass by or to flow around the monolith of the sealant. And finally, the stress. Because typical wells that are looking at CO2 are very high stress, repeated stress, injection and producing wells, this stress or ability to control the Young's modulus or its resiliency is really, really important. So normal cement fails miserably. If you assigned a 1 to 5 rating on the cement with each of these categories, it gets a 5 with the 4 categories. But we could also then look at like a fly ash cement. We could replace some of the calcium silicates with a fly ash, a reactive fly ash, and that helps a little bit. It just lowers the amount of reactive material, but again, as you go through the list, it only goes from 5 to a 7. It's mediocre at best. There's other things that we've used in the industry like latex. Latex is a liquid emulsion that lowers the set permeability of the cement. Well, how does that affect it? It affects it some. It affects the permeability and maybe a little bit of bonding and maybe a little bit with the stress. But again, it changes it from a 5 regular cement to maybe an 8. If we wanted the gold standard though, look at the RiLOCK resin. It has 0 calcium silicates. It has 0 permeability. It has 10-fold bonding increase over regular cement. It has magnitudes less Young's modulus, which really makes it a very resilient material. So if you're looking for the gold standard, you're looking for the go material in green, that's the RiLOCK resin. So in conclusion, RiLOCK resin, guess what, is an excellent solution for combating CO2 corrosion. Why? Because it has all the properties that we need. It has 0 permeability. It has no reactive constituents, therefore it cannot corrode. It has very high resiliency, so it's resistant to stress and repeated well interventions. It has high bonding and seal, doesn't allow for there's to be microannulus or lack of bond in both the formation and the pipe. And guess what? It's also very flexible in design. We can design it at whatever temperatures necessary or needed for the well. Here's the bottom line. RiLOCK resin is the ultimate seal for CO2 in wells. Just want you to remember before we go, RiTex is the one-stop shop for all your cementing needs. Second, RiTex has both the materials and the expertise to help you in well construction. We're here to help you. And finally, if you need to contact us, look at our website and jot down the number that's on your screen. We'll help you and provide whatever expertise you need. Thank you for watching.